Okay, guys, so it is Friday, the 6th of October, and as you can hear in my voice, I'm not really ready to get back in class, so I'm going to give you this short video lecture over chapter 7. What I want you to do today is read chapter 7, and then we're going to talk real briefly. Oh, we're going to get all the way up into 7.1, so not too far. uh, Compartments of chapter 7 were tying a lot of what we learned uh, from from chapters 2 and chapter 6 together. But we need to understand a few things as well. Weather and climate, there is a difference, and the main difference between the two has to do with the time. So weather is a snapshot. It's what's happening currently or what's happening at a very short period of time. And climate is weather over a period of time. And believe me, this is short, so we're gonna get through it. But I couldn't find a great video to show you for this part coming up. Uh, we have elements that contribute to weather. Obviously, temperature is going to impact it, right? Because what happens when we have a change in temperature? We have a, a gradient pressure difference, right? So that means that we're going to have some winds. That is weather. We're going to have air pressure, depending on uh, air parcels or air masses. The humidity in the air is going to impact weather, as you might remember, as an air parcel goes up. If it's very humid, if it's saturated, then it will probably drop out condensation, wind speed and the direction, and then seasonal factors like insolation and sun angle. So we can we can expect certain weather events to occur seasonally based off of our angle directing the sun, approaching the sun, and how much insolation we're receiving on the earth at that particular time. Remember, land and water react differently. We can't evaporate any land, so but we can evaporate over the oceans, and that means we're going to get a lot more humidity, and that's one of the bigger factors. Okay, so I think these are kind of at this point you should be able to think of a reason why at least each one of these might impact weather, and you will be able to by the end of this chapter. Well, I mentioned air parcels before, but what about air masses? An air mass is a uniform body. It doesn't really have a set size. Typically, they are defined um, not necessarily by their size, but by the content or its characteristics um, from where they come from. So, as you can imagine, we know it's colder up at the poles, and we have polar air masses that will come through. Well, again, this is kind of intuitive for this part. Well, we get to now name them. So don't forget that as an air mass, so these are not stationary. Typically, they're going to be moving. At least one will be. And if one is moving, they're going to start to take on the characteristics of their new location. You know that as you um, that's why air conditioning works, right? Uh, if you put different air into a stagnant air container of air or a room of air that's hot, and you blow cold air into it, the cold air tends to take on the feeling of the rest of the air, unless of there's more air in that air mass that comes in. So that's really kind of key in a couple of considerations. But let's look here. How do we classify air masses? Well, two things that we want to look at: moisture and temperature. And those are fairly easy to get. M for maritime, and we know that maritime means that there's water, and so that's going to be wet. So sometimes I've heard people say, well, think about the M and it's upside down, and that helps them remember it's water. But whatever you got to do. And then C for continental or dry. We know that there's typically little water on the land compared to the oceans. And so that's really what we're looking at. An ocean's, did it start an ocean source or did it start over a continent or land? And so we have M and C. We always put these as lowercase. So if you see these as lowercase, that's easy to get. And you can kind of a lot of times tell what's going to happen based off of if they're wet or dry. We already know some of those characteristics, what might happen or what could be happening based off of that. Okay, next, then we have temperature. Um, and this is also kind of easy to get if you think about it from the top of the globe. Arctic, A for Arctic at the very, very top. Peak coming down, so 90% latitude, maybe to 85 or so for Arctic, down to polar. And then as we come down further, we'll get tropical. Notice that there's not a mid-latitude temperature, right? It goes from polar to tropical because these are really cold, and then tropical and equatorial are warm. Well, oh, hold on. Then we have an Antarctic. Well, so we don't have anything in between. Well, we do have a polar that it could be down there, but typically there's not a big land mass or a bigger mass down there that we're going to have multiple different names as we get down lower. Think about where most of the energy is received on Earth. It's in the tropics. We know that the tropics are the warmest. So if it's a tropical, what would we expect? We'd expect it to be warm. Yeah, and those are warm. Equatorial, that's actually a little bit different, but it's also warm. We're going to see how these might impact. Equatorial should be warmer. Uh, Antarctic should also be very, very cold. Okay, and then we just display them as two sets of letters. Not always two letters, because sometimes there's three, right, for Antarctica, but two sets of letters. Maritime, tropical, lowercase m and t. So that means it's going to be a wet, warm air mass. And then a continental polar, a lowercase c and an uppercase p. Continental is going to be dry. Polar is going to be cold. And that also fits. We don't really see a lot of polar, we don't see a lot of maritime polar air masses. Why? Because cold air can't hold a lot of moisture. And that's just, think about where they come from. That's not occurring. So let's look at it on a map real quick. And I'm going to leave you with these to review again if you want to, but I know you don't want to hear me talk. Continental Arctic, really cold at the very, very top as it comes down. Then there might be a continental polar, right? Not the Arctic, but still cold, not as cold as the Arctic, but it's around there. And it's pushing down. These don't have anywhere else to go but push down. And that's typically what we see a lot. When would we expect to have these pushing further down? Well, when it's wintertime. So that's a seasonal effect. That makes sense. Maritime polar, we can see. And a lot of on these maps, especially at the beginning, we add color to them to represent, are they warm or are they cold, warm or cold? And so we'll see something like this. And you can read these. Let's go to the next one. We're talking about what would you expect in the summertime? Well, probably the polar and the Arctic to be smaller. And there we can kind of see that. They're not pushing down as hard. Where our tropical air masses are up higher than they were in the wintertime. So we've got two maritime tropical ones here. And then a really small continental tropical one here. Why? Well, Well, because it formed over this really small, relative to the ocean's landmass here in Mexico on this image. Okay, so that's pretty much what you need to know for these continental or for these air masses and the names. You just have to put those into memory and you look at these. Now remember, as these move, they're going to take on they're going to take on the characteristics of where they're moving into. And so with that being said, I also have assigned a video for you to watch, and it talks about air fronts um, and our weather fronts. And you're going to watch that. And if you read chapter 7 all the way up to 7.2, I think you're going to be great. So hopefully I'll have my voice back on Monday and we can get back at it. But thank you for your patience this week. And I hope you have an awesome weekend. Um, watch that other video for the extra credit. So I feel like that's a pretty good explanation. I've gotten some good answers from folks. So I know that I feel that those who are watching it are doing okay. So thank you very much.